Okay, so with the examples that we've looked at, we've been adding on this constant of integration each time. And what it seems to be is just adding on this little bit on the end, this bookmark, if you will, and it doesn't seem to be really doing anything. So I want to show you an example where actually we need to find that value of c. So let's say we've been given dy by dx, we've been given the gradient function, then we want to find y given that the curve passes through 1, 5, okay? So I know a particular point that the curve passes through. Now, in its current form, much like if we were going to differentiate, we can't integrate it like this. We've got to write it as x to the power of something in order to integrate it. This 3 over x squared, I can't work with that. So I've got to go back to my indices knowledge and know that this is 3 lots of 1 over x squared. So that's 3 lots of x to the minus 2. And I've still got that plus 4 in the end. So I need to know how to go from the 3 over x squared to the 3x to the minus 2. I can now integrate because I can add 1 to the power, so minus 2 plus 1 is minus 1, and divide by the new power. The 4 will integrate to 4x, and I've got that constant of integration c. So the equation that I'm dealing with is minus 3x to the minus 1 plus 4x plus c. That's the equation of the curve, or rather, that's the equation of a curve. Okay, because ultimately what I have with the fact that that c could be anything, it could be plus 100, it could be minus 500, whatever, I have actually found a whole family of curves. Okay, so I'm just drawing a generic curve here, okay, but they're all exactly the same curve, but they're depending on that value of c, it tells me which one it's going to be. So the fact that I know that it goes through 1, 5, okay, identifies that that is the curve that I want, and I don't want any of the others, okay? And knowing that one point will allow me to find the value of c, because now I can just substitute in those coordinates to find c. So if I substitute in y is 5 and x is 1, we get 5 is minus 3 plus 4 plus c. Okay, so minus 3 plus 4 is 1. Take 1 from both sides, so c is 4. Okay, so that means that the particular curve that I'm looking at is this. That is the curve that I want. That is precisely that curve. Okay, and it's not any of the others. And that's how we can find the constant of integration.